Okay, let's talk about work and power and how they are calculated, and we'll have the calculations as a separate video so that you can kind of work through those. Now we'll just talk about work and power. All right, hard work never killed anyone, but why take a chance? Well, work actually is done when you have a force acting on an object in the direction that it is moving. So any part of a force that's not going in the direction of motion, that does not do work. No movement, no work. So let's take a look at an example here. This guy right here participating in one of those world's strongest man competitions. He is definitely doing work. He is applying force forward, the truck is moving forward. There is movement and it is the direction he is applying force, work is being done. However, this lady here just pushing against the wall, just pushing, well, she's applying force to the right, but there is no actual movement to the right, therefore there is not going to be any work. Work is not being done. Also, think of it as you're picking up a heavy object and you're walking left and right. You're applying force up, but you're moving left and right. That also is not work. So let's bear that in mind and take a look at this example here. This guy right here, a weightlifter, holding this weight above his head, how much work is he doing? Well, even though I'm not going to say it's not that much, he's, from a physics point of view, not actually doing any work. He is holding it up there, and that does not, from a physics point of view, mean he's doing work. Now, yes, I know it's hard. No, I couldn't do that. I'm just saying there is not work being done while you're holding it up there. Keep this in mind though, he did work to lift the weight up. He was applying force up and the weight moved up. So he did work to get it there, but holding it up there, that is not, from a physics point of view, doing work. So in this case right here, you have a person moving through the airport carrying their luggage like that. A little weird, but from the point of view of physics, hey, they're actually doing work. This person is applying force to the right. The thing is moving to the right. So all the force is doing work. In this case right here, though, you're applying force kind of in a diagonal, up and to the right. The part that is going up is not actually work. The only part that is actually doing work is that component of it that's moving to the right. And of course, in this last example here, where you're applying force up and you're moving it to the right, that is not actually work. Force is up, movements to the right. Remember, force and direction, these two arrows here, need to be the same. That is work. This, however, is not work from a physics point of view. So how do we calculate work? Well, the amount of work is equal to the force times the distance. So work equals force times distance. Here's our equation pyramid. We're going to have some practice examples of that right here. If you want to jump ahead and click on that, you can get to some of those. The units for force, of course, is newtons. The units for distance is meters. And the units of work is newton meters or joules. So not jowls, joules, capital J. So that is what we're going to be using for calculation. Again, click here if you want to actually do some of the practice problems. Let's talk about power. Power is a little bit different. Power is how fast you do the work. Acceleration, if you recall from before, is how fast you get fast. Power is how fast you get the work done. So it's not does the work gets done. It's how quickly does that happen. Doing work at a faster rate requires more power. Doing work at a slower rate requires less power. The way we calculate that one is power equals work divided by time. More practice problems on that right here if you want to review that. Power is work divided by time. The units for power is joules per second or the watts. I said watts. Get it? Because it sounds like I'm saying watt. And okay, never mind. Anyways, watts, my units for power. So the unit for work is joule. Unit of time is seconds. Let's take a look at these examples here. Human with shovel, old lady with shovel technically, and a snowblower. Now who has more power? Well, the thing is, they are both doing the same amount of work. They are moving that snow from here to the neighbor's yard, if you're feeling like a jerk. The question is, which one has more power? Well, the answer to that is obviously the snowblower. It does the same amount of work, but it does it faster in less time. Here we have a lawnmower engine and here we have a jet engine. They burn the same fuel, more or less, but at different rates. Let's say a gallon of gasoline will last half an hour in a gas mower, but it might last half a second in a jet engine. Remember, they're doing the same amount of work, but obviously this one is doing it at a much slower rate than something like a jet engine. Everyone's been behind that old lady or the little baby climbing upstairs. You know it, and you're like, can I walk by him? Can I shove him aside? How do I politely tell them to move out of the way so I can get up there? And then, of course, there's those people there, sprinting up the stairs. The question is, who does more work? The answer, they're doing the same amount of work. They are moving their weight from the bottom to the top. Who has more power? Well, that's these ones here, the ones who are running. Why? Because they do it in less time. They do it faster. Same work, more power here because the time is less.